Hello everybody, welcome back to another video. In today's video we're going to solve a relatively difficult algebra problem. In particular, given that a squared plus b squared is equal to c squared plus d squared, which equals 85, and the absolute value of ac minus bd is equal to 40. Given all of this, what is the absolute value of AD plus BC? That's what we want to find. So ultimately, this problem isn't very difficult, but it does rely on a crucial algebraic trick. This isn't the only way to approach the problem, but this is the standard approach, and it relies on an algebraic trick. So, but once you have that algebraic trick in your toolkit, the rest of it is really just following your nose from there. So let's go ahead and kind of lay out what that trick looks like. So to start, consider the following. Consider this. Yeah, that's good. Let's consider this following product. Let's take a squared plus b squared and multiply it by c squared plus d squared. Well, because we already know, maybe I'll box these up above. We already know that this is true and this is true. And we want to kind of come up with some relationship between these two equations, or perhaps even this quantity as well. We want some relationship between these expressions that have two variables multiplied, and the first equation, which just has things being squared and added to each other, right? So that's where the trick comes into play. We want to establish some relationship between these two, and so here is the trick. If you take a squared plus b squared and multiply it by c squared plus d squared, we can actually write this in the following way. This is ac minus bd all squared plus ad plus bc all squared. Now, you might not even be convinced by this. Why would you even write this? Why is this true? Well, this is kind of the trick aspect of it. It's not really clear how you would make this jump until you've already seen this sort of thing before, and then it's something that's in your toolkit that you can readily employ later. But why don't we just kind of maybe well, here's what I'll do. I'll make a little like a question mark right here. I'll kind of leave that as like a tentative, maybe I'll use a different color. Um, this is just kind of tentatively true. I claim that it's true, but let's actually see why that is. And then after we see why it is, we'll cross out that question mark and proceed. So we'll just multiply this out. Multiplying this out, we get, well, you square the first term. Squaring that gives a squared c squared minus 2abcd. That's minus 2 times the product of each term. And lastly, we square the BD, getting us B squared D squared. Now for the second term, we square AD, we get A squared D squared. And this time we get a plus 2 ABCD. And lastly, plus B squared C squared. All right, perfect. And we already see there's some nice cancellation here. I'll note that in red. We've got minus 2ABCD here, and we've got plus 2ABCD here. So those cancel out, and ultimately all we're left with is A squared C squared plus B squared D squared plus A squared D squared plus B squared C squared. Now let's just kind of mentally check that this is true now. Maybe I'll write question marks all the way through. So now let's just mentally check that the left-hand side here, when we multiply this out, we do in fact get what's on the right-hand side. So we take a squared times c squared. That gives us a squared c squared. We take a squared times d squared. That gives us a squared d squared over here. So that checks out, that checks out. And we take b squared c squared. Checks out there. And we take b squared d squared. Okay, so we've just FOILed this out and verified that this formula is true. So now maybe what I'll do is I'll get rid of all of this stuff that we just wrote, because now we're convinced that this original equality here in this first line is true. So maybe I'll just erase all of this, just undo it all. So yeah, now that we're convinced that this is true, this is the key. This is the trick to solving this. There we go. Okay, so now we're convinced that this is true. This weird identity, this weird algebraic trick that we've uncovered, and now we're going to use it. Well, let's use our assumptions in the problem. A squared plus b squared is 85. So is c squared plus d squared. So in other words, this product here is just 85 times 85, or in other words, it's 85 squared. So that's the first thing to note. Next, I'm doing this a little bit informally, by the way. Next, the absolute value of AC minus BD is 40. So therefore, AC minus BD squared is just 40 squared. And now we're in a really good spot, because now we've got 40 squared plus the thing that we want to solve for squared equaling 85 squared. And now we just need to follow our nose, apply some basic algebra here to get this quantity. Maybe I'll underline it in green. We want to get this quantity isolated. So we subtract 40 squared from each side. So we get AD plus BC squared, all squared, is equal to, oops, I forgot a square up here. Props if you caught that. So yeah, this is AD plus BC all squared equals 85 squared minus 40 squared. All right, now we just need to solve for AD plus BC. That's what we want. We want the absolute value of AD plus BC. Remember that if you take the square root of something squared, it's the absolute value of that thing. So that's what we'll do. We'll take the square root of both sides here. So we get the absolute value of AD plus BC equals the square root of 85 squared minus 40 squared. And now I'm going to employ the difference of squares formula here. This is the same thing as 85 minus 40 times 85 plus 40. So we've employed the difference of squares formula. Maybe I'll write it up here just to be totally complete. If you have a squared minus b squared, it's a minus b times a plus b. Okay. Whoops. Okay. So now I'm not going to use a calculator here. I'd just like to carry out the calculations by hand. It's really not too bad. You're welcome to use a calculator at this stage, of course, um, but anyway, let's do it without it. So we take the square root. 85 minus 40 is 45. Actually, make this a little smaller. 85 minus 40 is 45. 85 plus 40 is 125. And now we want to write this thing as a perfect square somehow. We want to take the inside, write it as a perfect square. So we know that 45 is the same thing as, well, it's 9 times 5. 9 times 5, in other words, is 3 squared times 5, because 9 is 3 squared. And 125, that's the same thing as 5 to the third power. Double check that. Now lastly, we just need to kind of simplify this a little better. This is 3 squared times 5 to the fourth. Or in other words, this is 3. The square root of 3 squared is 3. The square root of 5 to the fourth is 5 squared. And so we multiplied these two together. 3 times 5 squared is 3 times 25, which is 75. So let's just kind of pan out and summarize our result and what we did in this problem. So we started off with this relationship with these two equations uh, relating these sums of squares to this more complicated looking product of variables. So we came up with this trick that we established here. After we employed that trick, it was just fundamentally coming down to isolating this underlined green term here and solving for it, which gave us the absolute value of 80 plus BC, and then just carrying out some arithmetic here gave us 75. So that's the end of this video. If you have any questions, please leave them in the comments, but otherwise I'll see you all in a future video. Have a great day.